Angel Norelie Cabradilla, and I'm an aeronautical engineering student, and here's what I learned on my subject Introduction to Aviation with Principles of Flight. Of course, you can't study a subject without knowing its history, so here's the people who contributed in aviation industry. First, we have Leonardo Da Vinci. He filled pages of his notebooks with sketches of proposed flying machines, but most of his ideas were flawed because he clung to the idea of bird-like wings. Robert Hooke. He concluded that the human body does not possess the strength to power artificial wings. Joseph and Etienne Montgolfier. In 1700s, or specifically in 1783, the first manned hot air balloon flew for 23 minutes. Professor Jacques Charles. 10 days later after the said event, he flew the first ever gas balloon. Next up is Sir George Cayley. Cayley discovered the basic principles on which the modern science of aeronautics is founded, built what is recognized as the first successful flying model, and tested the first full-size man-carrying aircraft. William Samuel Henson. He designed a huge monoplane that was propelled by a steam engine housed inside the fuselage. Otto Lilienthal. He proved that human flight in aircraft heavier than air was practical, worked toward the dream of powered flight. And lastly, the Wright Brothers. The bicycle-building Wright Brothers of Dayton, Ohio had experimented for 4 years with kites and their own homemade wind tunnel and different engines to power their biplane. Their biplane, called the Flyer, combined inspired design and engineering with superior craftsmanship. By the afternoon of December 17, 1903, near Kitty Hawk, North Carolina, the Wright brothers flew a total of 98 seconds on 4 flights. So now that we are through the history of aviation, we can now go to the aircraft structures. An aircraft has a lift and basic aerodynamics. 4 forces act upon an aircraft in relation to straight and level on accelerated flight. Thrust is the forward force produced by the power plant or propeller. Thrust. Drag is a rearward retarding force and is caused by disruption of airflow by the wing, fuselage, and other protruding objects. Weight is the combined load of the airplane itself, the crew, the fuel, and the cargo or baggage. Weight pulls the airplane downward because of the force of gravity. And lastly, the lift. Lift opposes the downward force of weight and is produced by the dynamic effect of the air acting on the wing. An aircraft also moves in 3 dimensions and is controlled by moving it about one or more of its axes. First axis is the longitudinal or the roll axis. This extends through the aircraft from nose to tail, with the line passing through the CG or the center of gravity. Second off is the lateral or pitch axis. This extends across the aircraft on a line through the wing tips, again passing through the center of gravity. Lastly, the vertical or yaw axis. This axis passes through the aircraft vertically and intersecting the CG. CG, or the center of gravity, is the theoretical point at which the entire weight of that body is assumed to be concentrated. Next up are the major components of an aircraft. We have the power plant. The power plant usually includes both engine and the propeller. The primary function of the engine is to provide the power to turn the propeller. Wings. The wings are airfoils attached to each side of the fuselage and are the main lifting surfaces that support the airplane in flight. The principal structural parts of the wing are spars, ribs, and the stringers. Spars carry flight loads and the weight of the wings while on the ground. Ribs determine the shape and thickness of the wing. And lastly, the stringers. These serve as the structural components that transfer loads and stresses. Next component is the empennage. The empennage includes the entire tail group and consists of fixed surfaces such as the vertical stabilizer and the horizontal stabilizers. The movable surfaces include the rudder, the elevator, and one or more trim tabs. Fourth component is the fuselage. The fuselage is the central body of an airplane and is designed to accommodate the crew, passengers, and the cargo. It also provides the structural connection for the wings and tail assembly. And lastly, the landing gear. The landing gear is the principal support of the airplane when parked, taxiing, taking off, or landing. The landing gear consists of 3 wheels, 2 main wheels and the third wheel positioned either at the front or the rear of the airplane. Now let's go to the types of aircraft construction. The construction of aircraft fuselage evolved from the early wood truss structural arrangements to monocoque shell structures to the current semi-monocoque shell structures. So let's now talk about the truss structure. The main drawback of truss structure is its lack of a streamlined shape. In this construction method, lengths of tubing called longerons are welded in place to form a well-braced framework. And vertical and horizontal struts are welded to the longerons and give the structure a square or rectangular shape when viewed from the end. Now we have the monocoque and the semi-monocoque construction. Monocoque construction uses stressed skin to support almost all loads. Although very strong, monocoque construction is not highly tolerant to the formation of the surface. And in semi-monocoque construction, this uses a substructure to which the airplane skin is attached. The substructure, which consists of bulkheads and or formers of various sizes and stringers, reinforces the strut skin by taking some of the bending stress from the fuselage. Let's now talk about principles of flight. In this part, we will examine the fundamental physical laws governing the forces acting on an aircraft in flight, and what effect these natural laws and forces have on the performance characteristics of aircraft. So let's now go over the structure of the atmosphere. The atmosphere is composed of 78% nitrogen, 21% oxygen, and 1% of other gases such as argon and helium. Some of these elements are heavier than others. The heavier elements, such as oxygen, settle to the surface of the Earth, while the lighter elements are lifted up to the region of higher altitude. Air, like fluid, is able to flow and change shape when subjected to even minute pressures because it lacks strong molecular cohesion. So after knowing the structure of the atmosphere, let's now get educated with the atmospheric pressure. Air is very light, but it has mass and is affected by the attraction of gravity. Therefore, like any other substance, it has weight, and because of its weight, it has force. Since it is a fluid-like substance, this force is exerted equally in all directions, and its effect on bodies within the air is called pressure. Under standard conditions at sea level, the average pressure exerted by the weight of the atmosphere is approximately 14.70 pounds per square inch of surface. The density of air has significant effects on the aircraft's performance because as air becomes less dense, it reduces power because the engine takes in less air, reduces thrust because a propeller is less efficient in thin air, and it reduces lift because the thin air exerts less force on the airfoils. In Newton's first law, it is stated that every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. An aircraft at rest on the ramp remains at rest unless a force strong enough to overcome its inertia is applied. Once it's moving, its inertia keeps it moving, subject to the various other forces acting on it. These forces may add to its motion, slow it down, or change its direction. Force is equal to the change in momentum per change in time. For a constant mass, force equals mass times acceleration. This takes into account the factors involved in overcoming Newton's first law. It covers both changes in direction and speed, including starting up from rest, positive acceleration, and coming to stop. The third law of Newton is, for every action, there is an equal and opposite reaction. In an airplane, the propeller moves and pushes back the air. Consequently, the air pushes the propeller and thus the airplane in the opposite direction. In a jet airplane, the engine pushes a blast of hot gases backward, and the forces of equal and opposite reaction pushes against the engine and forces the airplane to move forward. And lastly, Bernoulli's principle of differential pressure. Bernoulli's principle states that as the velocity of a moving fluid, liquid or gas, increases, the pressure within the fluid decreases. This principle explains what happens to air passing over the curve of the top of the airplane wing. As the wing moves through the air, the flow of air across the curved top surfaces increases in velocity, creating low pressure area. Thus, airplane wing develops lift. So that's my presentation on what I've learned in my subject Introduction to Aviation with Principles of Flight. Again, I am Angel Norelie Cabradilla from BS Aeronautical Engineering Section 1A. Thank you for watching and I hope you enjoyed going through the different topics with me. Thank you and God bless.